Hello, everyone. This is Natasha. Today I will be the host of this webinar. I would like to thank you once again for attending this 2025 Sustainability Best Paper Award ceremony. Please note that this webinar will be fully recorded and available online as soon as possible. Before I introduce you with today's speakers and also winners of this award for this year, I would like to introduce you with the journal and the company details. Okay, first I will tell a few more details about the company. MDPI is a pioneer in scholarly open access publishing. MDPI has supported the academic community since 1996. We are based in Basel, Switzerland, and MDPI has the mission to foster open scientific exchange in all forms across all the disciplines. Our 473 diverse and open access journals, including 464 peer-reviewed journals and 9 conference journals, are supported by more than 295,000 academic experts who share our mission, values, and commitment to providing high-quality service for all authors. Few details about the journal. Sustainability is an international, peer-reviewed, open access journal on environmental, but also cultural, economic, and social sustainability of human beings, published semi-monthly online by MDPI. And a few details about this award, Sustainability Best Paper Award. This award is sponsored by MDPI Journal Sustainability, and this award is granted annually to highlight publications of high-quality scientific significance and, of course, extensive influence. All papers published in the Sustainability Journal are eligible for this award, both regular and special issue submissions, and all applications are always assessed by an evaluation committee, which is led by our editor-in-chief, Professor Dr. Mark Rosen. More details about this award and all other awards you may find on the link on this slide. And today's program, I'm really proud to introduce you with our speakers. After this brief introduction, first speaker will be Professor Branislav Olech. Then second speaker will be Ms. Alyssa Jasmine Trudinger. Then Professor Eduardo Ordonez Ponce, Dr. Ravjit Kangura, and after each speaker finish with presentations, we will have Q&A session, and then the webinar will be closed. Also, I would like to use the opportunity to remind you that during webinar, you may ask questions. What that means? That means that during webinar, you may use Q&A box and write questions for our speakers. And during Q&A session, we will read each question and respond. The Q&A box is located between participants and pools, so be free to use it. And today's first speaker is Professor Branislav Olech from Faculty of Ecology and Environmental Science from Technical University in Zvolen, in Slovakia. Our second speaker will be Ms. Alyssa Jasmine Trudinger from Institute of Spatial and Regional Planning from University of Stuttgart, Germany. Third speaker will be Dr. Eduardo Ordonez Ponce from Faculty of Business from Athabasca University, Canada. And fourth speaker for today is Dr. Ravjit Kangura from Department of Primary Industries and Regional Development in Australia. And that's it from my side for this beginning and introduction. I would like to invite Professor Branislav to start. Thank you very much.
Hello, everybody. My name is Branislav Olech. I'm a professor of landscape ecology from the Faculty of Ecology and Natural Sciences from Slovakia. My background is a landscape ecology, and I started my research life with land use development using historical maps, aerial satellite images. And then I moved to the European Environment Agency in Copenhagen when I worked as a project manager for land use analysis and dealing mostly with corner land cover and analysis of corner land cover and changes. Here I was at the beginning of the so-called MICE process, which stands for Mapping and Ecosystems and Ecosystem Services. And I slightly moved my career towards ecosystem services. And after returning to my university, I started to research ecosystem services, and I focus mostly on regulatory ecosystem services. In the last years, me and my colleagues and our PhD students, we started to deal and to investigate mostly urban climate and trying to quantify effects that could be used as a prerogative or to assess the capacity of urban ecosystems to provide to ecosystem services, mostly toward addressing or mitigating urban climate. So the title of my presentation is the same as the winning paper in the Journal of Sustainability. And it was on quantification of the cooling effect and cooling distance on urban green spaces based on the vegetation structure and size, and possibly be used as a basis for management tools for mitigating urban climate. These are my co-authors, my colleagues from our university. But beyond this particular paper, I would like to introduce also our broader research, which is focused on urban heat island as general, and this mentioned cooling effects and cooling distance. And in the end of my presentation, I would share with you some views of our newest work or ongoing work on urban climate mitigation, soil infiltration, and carbon sequestration ecosystem services. Let me introduce our town, Zvolen. It's a small to medium town regarding to European standards, which lies in the center of Slovakia, in the very middle of Slovakia. The elevation is 300 meters. We have warm summer, humid continental climate with warm and hot summers and cold, snowy winters. This was also our initiative why to really deal with the urban heat island. It's a small town, around 40,000 inhabitants, which is lying in the basin and is surrounded with open agriculture and later on also forested landscapes. Our main research question, where we really started to think about this, is that is it true that urban heat island can manifest itself even in a small town? Of course, we knew that urban heat island is mostly promoted in large cities around millions inhabitants. But our question was, is it really true that we can detect it even on a small town? And this is the slide on study area that I was referring to our city in the middle of Slovakia and elevation and inhabitants. And just to have you a short view how it looks like, and it is really in the open landscape, agricultural landscape, and further there are our Slovak mountains reaching up to 1,000 meters. So the study question, research question was about the urban heat island and whether it can manifest itself even in a small town. This particle part was published in Remote Sensing journal in 2002. What we did, we took satellite images from Landsat, and over last 12 years, in summer months, you can see the dates, we analyzed land surface temperature from the thermal band of satellite images. And using statistical methods, we try to estimate whether these temperatures inside the town are different from the temperatures outside in our open landscapes. You can see the graph here in these years. What we also did was that we draw a line through the city and really trying to visualize urban heat island. And the line goes from the open landscape to the open landscape through the inhabitant area and to the city center. And you can see from this graph on the left that this really there is an island, there is a curve, and there are some drops in the curve where are mostly vegetated areas, and this has peak. There is a industrial zone in Zvolen. We also compared using one-way analysis of variance, ANOVA, we compared the differences between temperatures in urban areas, which are marked as SU and UA, which stands for suburban and dense urban, and OL, which stands for open landscapes. And we found that there is a significant difference between the open landscape temperatures and the inner city or urban, dense urban areas, which could climb up to +6 or +4 centigrade degrees. We also analyzed it in a whole year, and we divided our city into zones, which and these zones were based on imperviousness layer from the European Environment Agency, distinguishing dense urban fabric, discontinuous urban fabric, urban green spaces, open landscape. Then in our finished paper, we went further, and we focused whether the size and structure of the vegetation really affects the cooling effect and distance to which these green spaces cool the environment in the city. For this, we took in each year from 18 to 21 two scenes, mostly in summer. And we analyzed also land surface temperature. And later we try to distinguish different sorts of urban green spaces. And this was a combination. Detection of these urban green spaces was based on the MDPI index when we distinguish vegetated and non-vegetated areas. And we combined it with LIDAR data, with laser data, to distinguish so-called high vegetation and low vegetation. High vegetation stands for trees and bushes, and low vegetation for grasses. And we also take into account also size of these urban green spaces, and we divided it into 3 classes. Small urban green spaces up to 1,000 square meters, medium size from 1,000 to 1 hectare or 10,000 meters, and large urban spaces above 1 hectare. We did it for grass vegetation, but also for tree vegetation. These are our results. So I highlighted those which are the most significant, and these are differences between green tree large, this is an abbreviation, so that is tree vegetation compared to dense urban or large urban areas, and this is green tree large vegetation versus small urban areas, and also green grass large vegetation versus urban areas. This analysis proved that the size and the internal structure of vegetation really matters, and that it's significantly different. It's providing shade or providing a cooling effect to the non-vegetated areas. We also analyze the distance up to which this cooling effect is effective, and we did distance zones with a step of 300 meters because 30 meters, because 30 meters is the resolution of satellite images. So we couldn't go smaller than 30 meters. And as you can see on the right side on this graph, the most prevalent cooling effect is for green tree large. So it means tree vegetations with a large size and tree vegetation medium size, and then this last curve is green grass large. It means large grass areas. And in the end of our presentation, I would like to show you the ongoing work, what we do beyond satellite images and land surface temperature. We also do some ground research and on urban climate mitigation. And you can see on these pictures our stationary meteor stations where we measure temperature and humidity inside the town. On the bottom right picture, you can see the middle of the town, the city square, and on the left of it is a graph on the temperatures which could climb in July up to 40 degrees. We also did, beyond the stationary measurements, we also did mobile measurements, which is mounted to a bicycle. My PhD student has a track through the city. On this track, she's measuring the humidity and temperature. And we also use thermo cameras to use thermal images. Our other PhD student does a research on the water retention capacity of urban soils. On these pictures, you can see that she's taking samples of soil and then in a laboratory measuring it and assessing free retention capacity, and then these measurements are extrapolated for the whole city. Other students does carbon sequestration, and his work is based on use of LIDAR data and field measurements. When he compares the LIDAR data and the cloud of these points to his ground truth measurements, and from this, through a model, he models volume of biomass of tree, of wood biomass. From this biomass, we can assess the amount of carbon which is stored in this biomass, and this is the result. And even further, he tried also to estimate the monetary value of this carbon which is being stored in the city vegetation. The last part we do is a water infiltration capacity, which is in our neighbor city of Banská Bystrica, where our student does measuring of infiltration speed on this very small and very simple instrument. And these measurements is done on 60 sample points. 30 of them is on grass and 30 of them is under the tree canopy. And these are the results. On the left side, you can see the measurement points. These red plots are areas which are not public, so they are restricted for access. So the whole experiment is done on publicly available places. On the middle map, you can see hydraulic conductivity of soil, which stands for or express the capacity of the soil to really infiltrate the water and the speed of this infiltration. And on the right, there is a modeling results of what happens if there is a 30-minute precipitation of intensity of 30 millimeters, and how fast will the water puddles create and cause some problems for the local inhabitants. That was all for my side, and thank you for your attention.
Thank you very much, Professor Branislav, for this interesting presentation. I would like now to introduce and invite our second speaker. That's Ms. Alessa Jasmine Tridinger, to join us and share her slides.
Thank you for the opportunity to present my research today, and also thank you for this award. And we are very grateful for receiving this Best Paper Award, and that our research on climate resilience and resilience building and reconstruction is honored by this award. And our work is also, as you might see now, closely linked to this reconstruction processes in the Ahr Valley after the flood event of 2021. And this was not only scientifically a challenge, but also personally to see all this destruction in the Ahr Valley in 2021, and therefore also thank you for this award, and also thank you to the people that supported our work. Actually, we did a household survey in this paper that won the award, and therefore also the people in the Ahr Valley that took part in this survey helped us to do this research. Today I'm going to talk a little bit also about this household survey and the results from the household survey, but also about our current research and what we are doing in the moment. So it's we are actually at the moment doing something about critical infrastructures, sensitive infrastructures, and and how to build climate resilience in reconstruction. So and at the beginning, maybe I forgot my name, but I was already introduced by the other one. So I'm Alissa Tüdinger, and I'm from the Institute of Spatial and Regional Planning of the University of Stuttgart. So so as an introduction, or before really diving into our current research topics, I want to show maybe also the international audience what happened in the Ahr Valley in 2021. What was this flood disaster of July 2021? Maybe not everyone heard of it. So heavy rainfall induced massive flooding of rivers and streams in Western and Central Europe in 2021. On the right, you also see a picture from those flooding. So it looked like, looked really, really bad. And even houses were completely washed away. So this was also quite new, especially for Germany, to see this massive destruction. More than 180 people died in Germany. In total in Western Central Europe, I think something about 220. So Germany was hit especially hard, and 135 of those people died in the Ahr Valley. So the Ahr Valley was like hit especially hard. So also these pictures from the Ahr Valley. So it's a quite narrow and steep valley, and the Ahr, the river that is flowing there, normally has about 40-50 centimeters, and during this night there were water depths of about 8 to 10 meters. So you can't really imagine it, even if you're staying there and you think like, okay, how can the water be like 8 to 10 meters at this point? It's really bad. So the Ahr Valley, over 9,000 buildings were also severely damaged or destroyed. And to put it into context, the Ahr Valley is not really big. So I think all in all, there are something like 100,000 people. But in the Ahr Valley, where the destruction was, it's like 50,000 or something like that. So, and really a lot of buildings were destroyed, and also public and private infrastructure was severely affected. So also, for example, electricity was not working, and heating, and so on, and roads and bridges. A lot of, I think there are around 100 bridges in the Ahr Valley, and 70% of them also got destroyed. Then it's also difficult for emergency units to reach some parts, and so on. The damage in Rhineland-Palatinate was amounting to 18 billion euros, most of it in the Ahr Valley. And there were also reconstruction funds in Germany for the state of Rhineland-Palatinate, and also for the state of North Rhine-Westphalia. Those were the ones that were hit especially hard. And the reconstruction funds were for 30 billion euros. So also a lot of funding for reconstruction was available. And within this reconstruction process, there was a research project, the CAR project, for 3 years. And I also worked in this CAR project. We got 5 million euros from the Federal Ministry of Education and Research for scientifically accompanying the reconstruction processes. And we did a lot of different things, and also, for example, this household survey and the research on critical and sensitive infrastructures. So in Germany, flood prevention is a mandatory task in the Spatial Planning Act, and also in the Federal Building Code. So for those who are maybe not familiar with Germany and the laws here, the same applies to climate adaptation. And the basis for spatial planning measures in Germany to protect against river flooding is the floodplain areas and flood hazard maps, and it's the so-called HQ100. So that is an flood event that occurs statistically once in 100 years. And everything is based on this HQ 100. So for example, also building regulations and so on. And for example, in 2021, during this disaster, we also saw that maybe the HQ 100 due to climate change is not anymore the real HQ 100, because climate change is, is also changing those occurrences. And also after the flood, they had to revise the hazard maps, for example. So in this map that you can see here, the purple color is the flooding in 2021, and the thing that is marked with this blue lines, that is the new HQ 100, and the other thing what is really blue, that was the old HQ 100. So it's not it was much bigger than the HQ 100. So what about critical and sensitive infrastructures? In 2021, we saw a lot of cascading effects that are clearly visible in the Ahr Valley and also along the Erft River in North Rhine-Westphalia. And we also saw, or in our research, we saw that critical and sensitive infrastructures should be given special protection also outside the HQ 100. So that's maybe not enough, especially for such protection-worthy infrastructures. And what are protection-worthy infrastructures? Protection worthiness is a political normative concept, and also depending then on the political norm, critical as well as sensitive, endangering, and particularly meaningful infrastructures can be included. So critical infrastructures, I think that's well known and also quite good researched already. But for example, sensitive infrastructures, we also saw in the Ahr Valley, there's not so much research on sensitive infrastructures, and there are also not many, or not at all in Germany, laws for protecting sensitive infrastructures, like for example, schools for children with disabilities. That was also something where I will show it later to you, where we also did some research on. Yeah, and what does protection worthiness mean? So if you apply this in spatial planning, it means that certain land uses and spatial functions should be given greater weight in the question of protection, so that, for example, those infrastructures are located outside the HQ 100 or even more outside. Maybe in Germany we have the HQ extreme, which is an extreme event that happens rarely. So that sensitive and critical infrastructures should be also located outside this HQ extreme, so outside danger zones. So that's also a table on those sensitive and critical infrastructures that was also in a newer publication. So critical infrastructures, as I already said, that's quite a term that is used often and also defined quite good. So critical infrastructures are infrastructures whose failure or impairment results in long-lasting disruptions to the overall system or to the society. For example, transportation networks, water supply, electricity, power supply, telecommunication, and so on. And sensitive infrastructures, those are, for example, kindergarten, school, or senior citizens and care facilities, so where it is important to avoid personal injury to groups of people who are particularly vulnerable, so who require assistance from third parties in the event of an incident. And and for example, also in 2021, a lot of those sensitive infrastructures were affected, and also some people also died in those sensitive infrastructures, also partly due to bad preparedness, I would say. And this is why we should also give greater should look also better for such infrastructures. And also in our household survey, and I already said it, this household survey was also used in our award-winning paper. We also asked, for example, the people how they view relocation and settlement retreat, and if they consider settlement retreat to be a meaningful measure in terms of risk prevention and climate adaptation, and especially if they consider or if they think that particularly sensitive or critical infrastructures should be relocated from the immediate vicinity of the Ahr River. So this this diagram was also in our paper from 2023. And we saw that, a lot of people agreed with the statement that particularly sensitive critical infrastructures should be relocated from the immediate vicinity of the R River. And and also a lot of those infrastructures are at the moment actually located near the R River because, for example, imagine like care facilities or hospitals and so on. It's quite nice if there's a river and there are also some parks and so on, so that the patients can, for example, walk outside and and it looks also quite nice if the river is not flooded. So therefore, a lot of those facilities are located normally, also in Germany and some other regions are located near the rivers. And but in 2021, we also saw that there might occur some problems. And and in our household survey, as I said, a lot of the people we asked agreed that those infrastructures should be relocated from this location. And then I already mentioned at the beginning, that was also something where we took a deeper look at. It's the Levana School. It's a school for children with disabilities. So all of the children of the school have mental disabilities, and 30 of those, almost 100 children also have physical disabilities. So it's quite difficult for these children to be evacuated. And as you can see here in this picture, it's marked where the Levana School is located. So, and marked with a red arrow is where the entrance of the Levana School is. So it's directly at the R River, and also where the children normally should evacuate to. It's quite near to the river, and as you might see now in the next picture, that's the new HQ 100 floodplain. So the one that after the flood of 2021, after revising the HQ 100 floodplains, this is the new map, and as you can see, the school is completely flooded during HQ 100, and also marked here with an other red arrow. That's the street or the path where, for example, the school buses or the buses that can also evacuate children have to drive through. And as you can see, it's flooded more than 1 meter during HQ 100, so no buses or vans or transporters can drive through this road anymore. So it's quite difficult to evacuate the school, and also the users are highly vulnerable. So therefore we made a scientific statement in support of relocating the Levana School in 2023, and in September 2024, the district council also decided on relocating based on this scientific statement, and we also made a publication now on this scientific, or based on our research on these sensitive infrastructures. And why did we say that the school should be relocated? It's highly exposed, as you can see. So even during an rather it's not an extreme event, but during HQ 100, it's already flooded. And it's also highly vulnerable. So it's a school for children with disabilities. On the one hand, children are already quite vulnerable, especially if they are quite young. But if they have also disabilities, it's very difficult to evacuate them. So in terms of time, and also you need additional personnel. For example, some of the children, they need 4 persons to carry them outside. And then, as you can see, the HQ 100 is not, they do not only have to leave the building, but they also have to leave the whole area. So it takes takes some time to get out of this area. And also another thing is the school has only 1 floor, so you can't evacuate vertically. So that's why it's not wise to rebuild there. And you also need some technology. You need, for example, wheelchairs, or also for some children, they only can be carried when laying down. So you need those buses, but they can't arrive there. And it's also complex in terms of organization, and you need a lot of teachers and so on. And and also in 2021, we saw that there was actually no advance warning time. So we do not know how is it in the future. Of course, they try to make the early warning systems better, but nevertheless, for example, depending on where the heavy rainfall comes down, it's quite could be that there is also not so much advance warning time. So we do not know if we have like several hours for really evacuating the school or maybe not. And therefore we really recommended to relocate this highly sensible or vulnerable infrastructure and those children. And based on our research there, we also developed a risk assessment for sensitive infrastructures, a qualitative risk assessment. So it's based on what the IPCC and also some other researchers already developed. So risk is composed of hazard exposure and vulnerability. And vulnerability consists of, for example, coping capacity or and so on. And then depending on different questions and qualitative assessment, you can say, okay, is the risk rather high or rather low? And also then depending on if the risk is rather high or rather low, it's maybe wise to relocate, for example, or to take precautionary measures or building precautions and so on. And behind this risk assessment, there is, as I said, is rather qualitative. So there are different factors, for example, susceptibility or coping capacity. And and for example, you take a look then is, for example, vertical evacuation to a higher floor possible in a very short time? Or is it possible to evacuate also from this higher floor later on? Because in 2021, we also saw that there were some problems, not in schools, but because it was in the evening, but for example, also in private buildings, that sometimes the people, like they got up in the first floor, second floor, and so on, and then they couldn't get on the roof because there were, for example, no windows in the roof or anything, so they were like trapped under the roof. So it's also important to get on the roof, but then also later on how to get away from the roof, because also some people sat on the roof and then there were no helicopters that could fly in the night in 2021. So the people, they were also trapped on the roofs the whole night. And if you couldn't hold on any longer, some people also then died. So it's also important not just to evacuate vertically, but also what to do after that. So and also if the users can be informed, for example, of the need for vertical evacuation. Because, for example, also in 2021, there was a home for disabled people. And in the night of 2021, 12 people died in this care facility. And also because, it was the warning time was too short for them to get to the higher floors. And and all, so therefore, that's some things that should be considered. And also if the users are, for example, particularly susceptible, so if they have limited mobility, for example, or limited perception, ability to articulate, and so on. Then we also took a look at critical infrastructures and power supply, because power supply is like a very important critical infrastructure, because also a lot of other infrastructures are dependent on the power supply. So for example, there can also happen cascading effects if the electricity is not working anymore. Then, for example, there's also no more potable water, and then hospitals can't work anymore because a lot of hospitals have, for example, electricity supply for emergencies or emergency electricity supply, but not emergency potable water supply, for example. So you can't operate then anymore because of the hygienic situation and so on. So in 2021, also the power supply was hit, and also gas and so on. So also destroyed, as I already said in the beginning. And yeah, and we, for example, took a look at flood hazard maps for rivers and the criticality and how to identify those cascades of infrastructure failure. So, and and also on flash flood hazard maps, and those things were also published in an practical aid for example, power supply or distribution network operators and so on, so that they can also learn from the experiences from 2021 and Westnet's regional power distribution operator. They also worked together with us and also shared their experiences. And for example, one experience was that it is reasonable to relocate medium voltage stations outside the HQ extreme if possible. So as I already said, in Germany we have this HQ 100 and we also have an HQ extreme, which is something that occurs depending on the state in Germany. So some states have, for example, in some states the HQ extreme is kind of an HQ 100, HQ 200. In other states is an HQ 1000, and so on. So it's also depending on the state where you are in Germany, it's different, but it's it's better than using the HQ 100, of course. So to relocate medium voltage stations outside the HQ extreme if possible. So you can see it on the left side. Westnet's, this regional power distribution supply operator, they did it after the flood. So they said, okay, our medium voltage stations, they are already quite destroyed. So now we try to relocate them outside the HQ extreme so that if there's a next event, they are not destroyed anymore, and that at least this medium voltage stations, that they can be used also if an extreme event is happening. And if it's not possible to relocate those medium voltage stations, they raise the construction on an anchored base, so you can see it on the right side, so that it's also hopefully not affected during an HQ extreme. I already showed it. Then this criticality analysis also in this practical aid that I mentioned. So how to identify such cascading effects and and solutions to stop those cascades. Then risk-based urban land use planning. So what you can do in potentially areas that are potentially in a flood zone. And and also in regional planning, what you can do, for example, in regional planning, specifications for areas with high protection requirements and so on. And I think that's the last slide. So some of the challenges and recommendations from our research in the Ahr Valley, what we already saw during our 3 years of work in the CAR project. So in Germany, it's partly difficult to build resilience due to the protection of existing rights and also long planning periods. And there was a revision of the German building code also after the flood, and to partly counteract this long planning periods and existing rights. But I think there's still a long way to go for really building resilience in reconstruction. Also, sufficient information is required, for example, on vulnerability. So there's a federal spatial plan on flood protection in Germany, also since 2021. So they developed it before the flood, but after the flood, they were everyone was quite convinced to say, okay, now this federal spatial plan on flood protection should be, we should use it now, or but still there's sufficient information required to really do something. Then the identification of critical and sensitive infrastructures at the regional and local level is also necessary because, for example, at the moment, mostly critical infrastructures are identified on the state level in Germany or on the federal state level. But at the regional and local level, there are not so many, or not at all any methods for identifying critical and sensitive infrastructures, but especially, for example, in the R Valley, there were also a lot of those kind of smaller critical and sensitive infrastructures, and they also need to be identified beforehand, and then you also need to have some measures for those critical and sensitive infrastructures. And we also saw that the HQ 100 is often insufficient as a basis for planning, especially in the context of climate change and sensitive and critical infrastructures. So we should use other scenarios and maybe also revise those HQ 100 or maybe do it rather dynamically. And with regard to the question on-site reconstruction or relocation, we recommend to consider relocation, especially for critical and sensitive infrastructures like the Levana School, for example. So thank you very much for listening, and thank you.
Thank you very much, Ms. Alessa, for this very interesting presentation. Now I would like to invite our third speaker, that's Dr. Eduardo Ordonez Ponce, to introduce and of course start with his lecture. Thank you very much.
Thank you again, Natasha. Good morning, everyone, from Edmonton, Alberta, here in Canada, to the east of the Rocky Mountains. I hope you're all well wherever you are. My name is Eduardo Ordonez Ponce, and I'm an associate professor at Athabasca University, Faculty of Business. Thank you for inviting me to present my work at this important event. Really honored to be here. The title of this presentation is Exploring the Impact of the SDGs, the Sustainable Development Goals, on Sustainability Trends. This is a little bit different. This is based on secondary data, so sort of a different approach to research we have here. Is that moving?
Yes.
Okay, good. I would like to acknowledge and thank MDPI and Sustainability for this award, the committee members, and certainly congratulate my fellow colleagues here. Before I start with my presentation, just a little bit about myself. I have a bachelor's of engineering in industrial engineering, a master's of engineering in natural resources, and my PhD is in social and ecological sustainability, which I got from the University of Waterloo here in Canada. Before doing my PhD and in between, after my bachelor's, I worked basically as an engineer in social and environmental issues, and that's what led me to my PhD in social and ecological sustainability. And that professional experience actually really helped me in terms of the things that we do here at Athabasca University. We are an open university, and our students are basically adults. So my professional experience really relates to things that they do at work in terms of our teaching, in terms of our applied research too. A general perspective about my research. I will argue that my research is centered around sustainability management, focusing on diverse areas of research. I've done some work on sustainability partnerships in the context of climate change, cities, business models for sustainable cities, and I have also studied with colleagues the institutional context around the development of sustainability partnerships. With a colleague from EADA in Spain, we have studied the governance models of big corporations, and we're currently conducting some research on the institutional context that enable and inhibit their development with a focus on Europe and Latin America. With another colleague from Edith Cowan University in Western Australia, and another here at Athabasca University, we have published a couple of articles on sustainability education and research at higher education institutions. An important area of research for me is multinationals and sustainable communities. This is probably where I'm focusing most of my time now. This research focusing on remote communities from developing countries, the Lithium Triangle region in Latin America, Chile. I've conducted some work in Fiji. I'm in conversation with people in Brazil, and in developed communities as well. In Western Australia, we're about to conduct some research there by the end of the year, and hopefully Southern Alberta as well in the context of mining. Impact is the main focus of this work. And on the SDGs, I have assessed how cultural factors condition the success of countries in achieving the SDGs and their impact on sustainability trends, which is what I'm presenting today. That's a bit of an introduction in general terms. If you want to know more about the things that I'm doing, you can have a copy of that QR code there to have access to some of those publications. So how is all the research presented today connected? How do our work relate to each other? I will argue that through the SDGs. The SDGs were launched in 2015 by the United Nations in agreement with 195 countries. I would argue that Professor Ola and colleagues' research contributes at least, and based on my limited knowledge, to SDG 13 on climate action, SDG 7 on energy, SDG 11 on sustainable cities and communities. As we just saw Mrs. Schrödinger and colleagues' work, I will argue that again contribute to SDG 13 on climate action, and certainly to the development of sustainable cities and communities. And Dr. Kangura and colleagues, which is coming up after my presentation, I would say that at least their work contributes to SDG 13 again on climate action, SDG 15, life on land, SDG 9, industry, innovation and infrastructure, and certainly SDG 2 on zero hunger. That's related to food. And my research in general explores how the impact of the SDGs have impacted sustainability as a global trend. The SDGs have been presented as the greatest agreement ever achieved on sustainability, a shift in the sustainability movement. However, how successful have they been? Has sustainable development really improved thanks to the existence of the SDGs? I would argue that answering these questions is relevant not just to assess the SDGs, but also to understand what they mean and aim to achieve. And furthermore, since they will be hardly achieved by 2030, and there are a couple of articles at least referring to that, I'll also argue that we need to learn from their implementation so that a new sustainability framework, such as the SDGs or the Millennium Development Goals before the SDGs, will probably have to be launched around 2030. So by designing and doing a proper assessment of the success or failure of the SDGs, we can have higher chances of achieving their purpose, the new purpose of the new framework which we have probably after 2030. Briefly, in terms of academic literature, the SDGs have been widely studied across sectors and geographies, highlighting their strengths, limitations, and certainly some contradictions. For example, my own research shows that multinational enterprises have contributed to specific SDGs, such as the development of education, improvement of health, cities, and reduction of poverty. However, they have over-focused on India and China, certainly because they are part of this multinational supply chain, and that increases inequality among developing nations. I have also found that local culture plays a key role in achieving the SDGs. However, it's hard to link what organizations do in general, not only from the private sector, but organizations in general, what they do with sustainability progress. In terms of progress, research shows that not a single SDG is on track, and they will be hardly achieved by 2030. With respect to my methods and to answer the research questions, I used the Sustainable Development Goals as a framework, selecting specific variables to assess progress on the goals. The SDGs are composed by, as you saw in the picture, by 17 different goals and 169 targets or different variables. So I collected secondary data from reliable sources with information on sustainability methods from 2000 to 2022 to have a pre-period and a post-period with respect to 2015 when the SDGs were launched. And data was organized per country and regions. And the hypothesis of this research is basically that significant statistical changes have occurred since the SDGs were launched in 2015 regarding the trends that sustainability or the goals followed before that. And the test used for analysis was Wilkinson's rank test. These are the data was normally distributed, and that's a test for comparing the samples. And for clustering, I used the SDG's wedding cake, which was developed and proposed in 2016 by Johan Rockström and Sudhet. These are the variables studied in the respected sources. If you're interested in the detail, you can certainly check them in the article. For example, with respect to SDG 1 or poverty, we use poverty rate. With respect to SDG 4, quality of education, we used out of school children rate, or the Gini index with respect to reduced inequalities. On the results, when comparing the periods 2015 and 2016-2022, significant improvements were found regarding the reduction of hunger, improvement of health, water and access to energy, the development of cities, and improvement of oceanic life, everywhere except in Africa. On the contrary, significant deteriorations were found regarding economic development and work, except for Sub-Saharan Africa, and on biodiversity, except in North America. These results lead to the following graph. Here we have significant changes on the horizontal axis and improvements or deteriorations on the vertical axis. At the bottom right, we see significant deterioration on SDG 8, decent work and economic growth, and on SDG 15, which is about life on land or biodiversity in general. And at the top right, we see significant improvements in these social SDGs, zero food, good health and well-being, affordable and clean energy, and sustainable cities and communities, and on these environmental goals, clean water and sanitation, and life below water. All the other SDGs on the left of the figure have not shown significant changes, even though there are some improvements and then some deteriorations, but these were not found to be significant. So the discussion. Finally, most of the SDGs have not progressed significantly. Half of the environmental and social SDGs have improved significantly. Water and oceans in terms of environmental SDGs, and hunger, health, energy, and cities, which are social SDGs, except in the African continent. Biodiversity deteriorated significantly, except in North America, and there were no significant changes with respect to the improvement of poverty, the improvement of education, gender equality, or the development of peace and justice as institutions. And almost all economic SDGs have now significantly changed. Industrial innovation, inequalities, consumption and production, and work and growth deteriorated significantly, except in Sub-Saharan Africa. In conclusion, we're certainly not doing enough on measuring and monitoring, not only reporting the SDGs, which is basically what organizations do, remains a need. It's not enough to have communicationally successful frameworks. The SDG has been used as a framework, mostly I will argue as a communication platform, but concrete actions and programs must be achieved and will risk contributing to SDG washing more than to sustainable development. And SDG washing is related certainly to greenwashing, but with respect to the SDGs. While the dimensions of sustainable development are hardly progressing coherently and consistently, it's even harder to accomplish an integrating sustainability approach, integrating all of these dimensions, either the three classical dimensions of sustainability, economic, environmental and social, the cultural dimension as well, into that approach. As the SDG contradictions seem to play a crucial role in the limited progress made so far. For example, promoting economic development while at the same time trying to reduce GHG emissions, which is related to climate change. And hopefully this research, just like what we have seen from Professor Ola and Ms. Trödinger, The implications of research like this will be considered by practitioners and policymakers as we approach, in this particular context of my research, as we approach 2030, when a new framework, I will argue, will be needed and will be probably, it's already probably being discussed by policymakers and certainly probably the United Nations in terms of how we approach the next 15 to 30 years around the sustainability challenges that we're facing and around the lack of success and progress that we have made. Thank you for your attention.
Thank you, Dr. Ordonez, very much for this very important and interesting topic. Once again, I would like to congratulate you on this award. And I would like to invite our last speaker, that's Dr. Ravjit. If you are ready, you can maybe start with sharing screen, and we are looking forward to hear your presentation.
Okay. Good morning, good afternoon, and good evening, wherever you are. And thank you for joining this webinar. First of all, I would like to thank to Sustainability for the award and also for providing me the opportunity to share some of the findings of the literature review on regenerative agriculture. This has been an amazing journey to review a topic which you all know is incredibly complex, as the name implies. I'm so grateful to my co-authors, David Ferris, Cameron Wegg, and Jamie Boyer, for their tremendous support and contributions to this review. Here is what I will cover today. I'll start by clarifying what regenerative agriculture really means and its core objectives. Then I'll explore the scientific evidence behind various regen ag practices, particularly focusing on soil biology and ecosystem mechanisms. I'll highlight key findings from literature, identifying knowledge gaps, and conclude with some recommendations for future research and practical implementation. The aim is to keep this both informative and grounded in evidence. The objectives of regen agriculture are ambitious yet holistic. At its core, regen ag aims to improve the productive potential of both soil and environment. It is not just about yields, it is about doing more with less, using internal resources over external inputs, sustaining yields over the long term, and improving farmer well-being and human health. Ultimately, regen ag aspires to be part of the climate change solution through a system-wide integrated approach. Despite widespread interest in regen agriculture, so there has been no universally agreed definition. There are quite a few definitions from both academic literature and practitioner sources. Recently, Newton and co-workers reviewed a large number of published studies and grade literature based upon 229 journal articles and 25 practitioner websites. Unfortunately, they haven't given any definition, but instead suggested that regen ag can be either process or outcome-based approach or a combination of both, and the individual users of the term to define it for their own purpose and context. This slide presents a concise overview of regen agriculture in action. On the left, we see the core principles such as minimizing soil disturbance, maintaining cover, and integrating livestock. These principles guide the practical choices shown in the second column, like cover cropping, intercropping, and rotational grazing. As a result, we gain benefits including better soil health, increased carbon, nutrient-rich food, and reduced greenhouse gas emissions. Mechanistically, these outcomes are underpinned by processes like the liquid carbon pathway and enhanced below and above ground biodiversity. Despite the purported benefits, regen ag is not being adopted by the mainstream growers, as often they view the claims are overstated and lacking robust empirical evidence. So the aim of this review was to gather and assess existing research on individual regen ag practices, as there have been no field trials or studies conducted that evaluate regen agriculture as a whole system incorporating most of its core principles. So we know that soil health is central to Region Ag, as defined by the Intergovernmental Technical Panel on Soils. It is about the soil's ability to sustain productivity, biodiversity, and ecosystem services. This is a broader than just nutrient content or yield. It speaks to the soil's overall ecological function. A healthy soil is biologically active, structurally stable, and resistant to various stressors. Soil organic carbon is one of the primary drivers of soil health and interacts with its physical, chemical, and biological aspects, and is very crucial for carrying out a range of soil functions such as nutrient cycling, water retention, soil structure, aeration, biodiversity, and so forth that are already well documented in literature. If you look at the soil organic carbon distribution on a global scale, most agricultural soils in the world are very low in organic carbon. And in Western Australia, as you can see here, the carbon stocks are at the lowest end of the scale, especially in the northern and eastern grain belts, and these stocks are further declining due to erosion. The Region Ag proponents believe that soil organic carbon can be brought back into the paddocks by implementing good management practices that I will outline in the next few slides. Due to time constraints, it is not possible for me to go through such a comprehensive review, so I will just present some of the highlights. The first principle of Region Ag is to minimize soil disturbance to prevent soil erosion and increase soil organic carbon, with the other obvious benefits due to increased carbon in the soil. This is best achieved by implementing no or minimum tillage. This practice not only benefits the environment but can also reduce fuel and labor costs for farmers. So it is a win-win situation, though its adoption depends on crop type and region. The impact of tillage practices on soil organic carbon stocks has been widely debated. A substantial body of evidence, however, supports the view that transitioning from conventional tillage to no-tillage practices can improve soil organic carbon levels. For example, a meta-analysis by Hadaway and co-workers, based upon 351 peer-reviewed studies, found that no-tillage significantly increased soil organic carbon concentration, but in the top 15 centimeters of soil compared to high-intensity tillage. Furthermore, no tillage also resulted in high total carbon stocks down to 30 centimeter depth. However, beyond this depth, the difference in soil organic carbon were not significantly different. So these findings indicate that no tillage enhances soil organic carbon, primarily in the surface soil, which, although beneficial, may also become vulnerable to erosion if not protected by surface residue or cover crops. Now, the soil organic carbon is critical for sustainable production. In addition to improving the physical and chemical properties of soil, there is a growing evidence that soil organic carbon can also enhance crop yield and nitrogen use efficiency. Using a meta-analysis of published empirical data, Oldfield and co-workers developed a quantitative model to explore how soil organic carbon relates to maize and wheat yields, accounting for co-varying factors such as management practices, soil type, and climate. Their analysis showed that yields of both crops increased with higher soil organic carbon concentrations. However, the relationship was not linear, with yield benefits plateauing at around 2% soil organic carbon. This has important implications for soils with low organic matter, which may benefit most from practices that build soil organic carbon. The study also examined whether increasing soil organic carbon could also reduce reliance on nitrogen fertilizers. They estimated that improvements in soil organic carbon could potentially reduce nitrogen fertilizer requirements by up to 5% of global nitrogen input in wheat production. So these findings provide strong evidence that building soil organic matter not only supports higher yields, but also contributes to more efficient and sustainable nutrient management. This slide summarizes findings from Bradford and colleagues who assessed the long-term effects of different tillage systems over a 27-year period in a semi-arid environment. During the 20 years, reduced tillage treatments, including no-till, consistently outperformed traditional tillage in terms of grain yield, especially when fertilizers were applied. The higher yields under long-term no-till were attributed to improvements in soil structure, enhanced soil biology, particularly macrofauna, and greater water storage and better water use efficiency. So these results clearly demonstrate the cumulative and lasting benefits of sustained no-till practices for both soil health as well as agricultural productivity. However, this study conducted by Pitelko and co-workers raises an important caveat. While no-till has many benefits, it doesn't always improve yields, especially in wheat. As you can see in this graph, under rain-fed conditions in dry climates, it performs better. So this shows that region ag must be adapted to local context, as it isn't a one-size-fits-all approach. In fact, the meta-analysis confirms findings from earlier studies showing that no-till performs better in arid or semi-arid regions where water limits crop growth, a scenario that closely reflects much of Western Australia's environment. The next region ag principle is to keep soils covered. Covering soil with residues or mulch supports multiple soil functions. It protects against erosion, moderates temperature, improves water retention, and encourages biodiversity. This can be achieved by implementing various management practices, and one such practice is residue retention. Literature shows that residue retention does increase soil organic carbon. Researchers from Eastern Australia looked at the effect of stubble retention on soil organic carbon at two different sites in Queensland. At both sites, retained stubble had significantly higher soil organic carbon compared to stubble removal. So this shows that stubble retention is very important, particularly to improve soil organic carbon in soils that are severely depleted in organic carbon. The third principle of region ag is to keep the living roots in soil for year-round or as long as possible, and the benefits are similar to other conservation agricultural practices. Cover crops are key to this principle. They help reduce compaction, suppress weeds, increase microbial activity, and improve water infiltration. They also play a role in nutrient cycling, especially for nitrogen and phosphorus. This is one of the most versatile tools in the region ag toolbox. But cover crops aren't without challenges. Farmers often cite establishment costs, water use competition, and management complexity as barriers. This highlights the need for more research in this space to explore the suitable regions, type of cover crops, termination methods, to incorporate cover crops as a useful practice in farming systems. It is important to emphasize that cover cropping is only feasible in regions with either irrigation, adequate summer rainfall, or reliable off-season rainfall. Without sufficient moisture, the establishment and growth of cover crops becomes impractical, and particularly in dryland systems. The fifth and final principle of region ag is to integrate livestock to diversify income streams, support agronomic and environmental improvements through nutrient recycling from manure, and help manage pests naturally by enhancing ecosystem balance. A commonly recommended practice aligned with this practice is rotational grazing. This approach involves short intensive grazing periods, often with high stocking rates, followed by extended resting periods. The goal is to allow sufficient time for grazed paddocks to recover, which can lead to increased soil organic carbon, greater biodiversity, and enhanced system resilience compared to continuous grazing systems. Research by Moshe and colleagues has shown that rotational grazing can result in a 13% increase in soil carbon, a 9% increase in nitrogen, and more persistent forms of organic carbon than conventional grazing systems. This is a classical snapshot of carbon sequestration potential of various management practices in the top 20 to 30 centimeter soil. There are two main strategies to build soil carbon. First is to increase carbon input, and the second one is to reduce soil organic carbon losses. Practices that have the highest sequestration potential include composting, no tillage, and catch or cover crops. This has significant implications for climate change mitigation. The carbon sequestration potential of mineral nitrogen fertilizers is almost neutral, and bare fallow has the negative potential, of course, due to loss of carbon stock, and you can see clearly on the very left-hand side box plot in this graph. As you can see, the most of the management practices are compatible with the Regen Ag principles. So this evidence base further strengthens the view that Regen Ag concept is based upon solid principles and sound practices. Soil biodiversity is fundamental to healthy and productive potential of soils. It is a hidden powerhouse. In just 1 gram of soil, there can be over 200 fungal species, along with bacteria, nematodes, and microfauna. These organisms drive nutrient cycling, disease suppression, and soil structure. Globally, the value of these services is estimated in trillions of dollars, highlighting just how vital it is to protect this underground ecosystem. This global map underscores the uneven distribution of soil biodiversity and highlights regions that may be particularly vulnerable. As we can consider Regen Ag strategies, we need to think about preserving and enhancing this valuable biological resource by implementing appropriate management practices. Excessive use of synthetic pesticides can negatively impact soil organisms, reduce biodiversity, and consequently disrupt nutrient cycling. Gunstone and co-workers analyzed over 2,800 parameters to assess how farm chemicals affect soil life. The findings are sobering. Many agrochemicals have negative impacts on invertebrates essential to soil function. So Regen Ag seeks to reduce reliance on these inputs and build healthier self-sustaining ecosystems. This slide provides a snapshot of how Regen Ag practices contribute to ecological processes, from carbon regulation and nutrient transfer to plant hormone signaling. Understanding these mechanisms helps validate the scientific credibility of Regen Ag. Due to time constraints, I will quickly go through only a couple of these mechanisms. The microbial carbon pump is a fascinating concept. Microbes break down organic material and stabilize carbon in the soil as microbial necromass. This stable form of carbon is less prone to loss and contributes significantly to long-term sequestration. Role of mycorrhizal fungi in the transport of water is long debated. Research conducted by Kakouidis and co-workers in 2020 demonstrated that arbuscular mycorrhizal fungi play a critical role in water transport, accounting for over 46% of water uptake in some cases. This suggests that enhancing fungal networks through Regen Ag practices could improve drought resilience, a crucial benefit under climate change. This is a very fine piece of work and will be nice to have it verified under real field conditions. To summarize, regen ag practices can increase soil organic carbon, improve soil health, and positively impact biodiversity. But the results vary by region, soil type, and management history. This reinforces the need for tailored approaches rather than blanket solutions. Despite encouraging results, there are still gaps in knowledge, especially in long-term data, soil biology interactions, and region-specific outcomes. More R&D is needed, including trials in different agroclimatic zones, better extension services, and the removal of adoption barriers. I'd like to end with this quote from Professor Dr. Ratan Lal, who is a leader in soil science. His message reminds us that if we expect farmers to adopt practices that benefit everyone, from the environment to society, we must support and incentivize them, not penalize them. Thank you all for your time and attention.
Thank you, Dr. Ravjit, for this really amazing presentation. Also, I would like to use the opportunity once again to thank all our speakers and winners today. And according to our schedule, now we have Q&A part. And as far as I see, no questions asked in a Q&A box. But in case maybe speakers has questions for each other, now it's an ideal opportunity to do that. Of course, that's not mandatory in case there is no questions. Yes, Dr. Eduardo?
Yeah,
Sure.
thank you. Thank you, Natasha. Yeah, well, thanks. I would like to thank everybody for their presentations. I mean, this is really, really interesting and different topics. Really amazing work that our colleagues are doing. I had a couple of questions for Professor Ola, if I may, on his presentation. He mentioned a few things around maybe he didn't use the same word, but heat sources, the places where heat levels were higher, and I was wondering around the implications of that, on whether you could have you started collaborating with authorities and some of the implications of that research with respect to those particular places where heat areas or heat sources were higher? I don't know if that's a clear question.
Well, we didn't really consider heat sources. What we did was a kind of a reflectance of heat per surface. So we found that the mostly mineral surfaces are hotter, but we are discussing with the municipalities, and in our next phase we would like to really analyze hotspots in the city. So to analyze where the people live, where they move around the day, and where are they exposed most to the heat. It's not because it's not only the heat which is like, because what I presented is from satellite image is around 10 a.m. So it's a morning temperature. But the temperature in the city is more complex because it's affected by the sun and the time of the day and the shade of the building and all this. So it moves, and it's also there is also a effect of cumulative heat. So the surface is accumulating heat during the day, and then during the night it's heating it back. So it's very important to know where the people are, and especially in the nights. So if they sleep in the buildings which are really heated up during the day, that might be also the problem. So in our next research, we would like to really take this into account and to really to model the movement and the situation during the day where the people live or where they move through the city, and compare it with the actual temperature, which is also kind of shifting in the city because of the sun and of the day. And we consider this quantification effect very important because everybody knows that the urban greenery cools the environment. But the question is how much and how far. So if we identify these hotspots in the city, and then we can really promote either revitalization of the area or building or construction of some green areas, and we can calculate how big and what the composition of the green area could be. So if it's a medium size with trees is enough, or you have to enrich the size and the structure of the green space. So this would be our goal in the future.
Now, are there certain species that are more better suited to control heat than others, or is it just tree cover in general?
We didn't really consider the tree species. We took it as a trees, bushes, and grass. But of course, some of them, it's based on the physiology of the species, how much, because the cooling effect basically depends on two things. It's the density of the vegetation and the kind of buffer or isolation of the surface from the heat. And then second aspect is evapotranspiration of living of the tree or of the vegetation. So this, but these differences are very minimal, I would say. It's mostly about from the volume of the vegetation, because the tree species one to each other. Of course, there are the differences, but they are very, very minimal to be considered.
Okay. And then again, those species obviously will vary depending on the location, related to the climate, and the other implications of maybe inserting native versus foreign species that will benefit, heat control, if you will, but will create some other impact in some other areas, maybe.
Well, maybe not really in the sense of climate mitigation, but there's also this kind of multi-effect of vegetation. They provide several ecosystem services, and regarding biodiversity or natural processes, of course, local species are better than introduced species. So this is kind of thing.
And then finally, if I may, I saw that water is not as relevant as, trees is the most relevant variable that I mentioned, or species in order to control heat. But water sources are not very relevant. I think one of the graphs that you show, it was at the bottom of the
It's not so, because water is very relevant, I would say, in the city.
Okay.
Even stationary water, or also moving water, or some kind of these fountains in the city to really cool the air through the mists. So it is really, and it's called this green stuff is called green infrastructure, and blue stuff is called blue infrastructure in the cities, or at least in Europe we call it this way. So it is really relevant, but we didn't really took it into consideration in this stage. Of course, we did some research on some regression curve, and it really showed in this graph you're referring to the water is maybe the most important, but it lacks the shadowing effect, of course. But we know the water has a thermal capacity to really accumulate and then hold it, and then it slowly release it. So it's a very important kind of cooling agent in the city.
Yeah, so a moderating and mitigating effect, right? Yeah. All right, very interesting. Thank you.
Thank you. Thank you for questions.
Thank you.
Thank you both. As far as I can see, still no any questions in Q&A box. Therefore, I would like to mention to all our attendees, in case they have any questions for the speakers, they are more than welcome to contact us, and we will forward the questions. Then I will use the opportunity to thank you once again for joining the Sustainability Webinar 2025 Sustainability Best Paper Awards ceremony. I would also like to remind you that the whole webinar has been recorded and will be available as soon as possible online. Also, I would like to remind you to collect and download your certificates, and you can do that in option My Certificate on the link of the webinar. And certificates will be available as soon as we close the webinar. And be free to fill the survey, and we can say grade this webinar and share your feedback with us. that's it from my side. Once again, I would like to wish you all the best in your future research. And of course, it was a pleasure to meet you and having you today. Have a great rest of the day or night. Goodbye.